Okay. All right. Welcome to the workshop.
Good. Yeah. Good morning, everyone. I guess, yeah, today is GIS day. So we have a number of activities going on this morning. So the first one we are starting today is with the workshop on getting started with CyberGISX that Drew and myself will be leading. We, of course, have a poster session right after this, as well as our afternoon sessions, which are both in person and on via Zoom and streaming via Zoom. So that's kind of the activities for today. So any questions or anything else before we get started on the workshop? Okay, if not, maybe we get the workshop started. So this workshop will, as the name suggests, is going to cover what CyberGISX is and get you kind of prepared to using CyberGISX. Just give you a walkthrough, an example of what CyberGISX is, what are the concepts behind it, as well as give you some hands-on experience using kind of how to use CyberGISX.
Okay, so let's get started.
Yeah, so yeah, we can get started. So I'll pass on the ball to Drew. Drew, you can get started.
Okay, so quick introduction to myself. My name is Drew Lee. I'm a research programmer here at the CyberJs Center. So I will present this workshop together with Anna. So Anna, you want to give a quick introduction as well?
Yeah, and I'm a research associate professor in the Department of Geography and GIS Science, as well as with the CyberGIS Center. And as Drew said, we'll be presenting this workshop together. Yeah, and I guess it's great to see such a good participation for the GIS Day event to start with. And I hope you all get started getting to know about CyberGISX and getting used to using CyberGISX. So thank you, and passing on the ball back to Drew.
Okay, thank you. Yeah, so this is our agenda for this workshop. So first we'll have about 15-minute presentation, and then we have several hands-on session, and then we have a concluding remark, and then Q&A session. So first, what is CyberGIS? So if we put it in short, CyberGIS is the geographic information science and system based on advanced cyber infrastructure. So it's a cross-disciplinary research field that combines GIS and the cyber infrastructure, especially for resolving computational and data-intensive geospatial problems. Then what's the CyberGISX? CyberGISX is one of the many products come from the CyberGIS research. So it's a open online platform that enables researchers from different domains to access the latest CyberGIS capabilities for conducting computational and data-intensive geospatial analytics. And also here, that's the link to this platform. Later, we will have a hands-on session to go through this in details. Currently, we have the users from the geography domains, of course, and also we have the users from agriculture, from water science, hydrology, from the public health, also as the letter X means expansion. So CyberGISX expanding to even more related domains. Before we dive into what CyberGISX is, so let's have a quick review on Jupyter Notebook. So Jupyter Notebook is a relatively new tool that has changed the way how we do programming, especially for data exploration. So it's a open source software you can install on your local computer, and it enables you to do interactive programming in your browser. So like the snapshot here, so you open your browser and you type in your code and you can run it and you can see the result right away. So it combines live codes output, visualization, and your comments, your test, and multimedia resources into one Jupyter Notebook file. And currently, Jupyter Notebook supports more than 40 programming languages. So there's a code. A researcher published a paper on Nature about 3 years ago. He said we went from Jupyter notebooks not existing some 6 years ago to, in sense, everybody is using them today. So Jupyter notebook is really a new way for us to do programming. And our CyberGISX is built on top of the Jupyter notebook. However, there are still a lot of things Jupyter notebook cannot resolve or say beyond the scope of Jupyter notebook. So for example, to do geospatial analytics, you need to have a computing environment. And just like your phone, right? You need to install app into them. So to do the geospatial analytics, you need to have geospatial modules, libraries, and tools. That's something you need to handle by yourself if you install the Jupyter notebook locally on your computer. Also, there are many times we need to access to more powerful compute resources. So if you just have a notebook on your local computer, you are limited to the computer resources you have. And also, Jupyter notebook is a good way to share your research with others. But how to share them, how to find others' research, how to find others' notebook, to email them, that would work, but there must be a better way to do it. And you can discover others' work, notebook, and you can run them, and you can build on top of them. And once you finish your research, you can share your notebook with others. Also, this related to the reproducibility issue. So normally the notebook is detached from the environment the notebook is running. So when you share your notebook, how would you ensure, okay, your notebook can run on others' computer, right? Also, the bottom line is we want to keep the entry bar low for new users, because the goal of the Jupyter notebook is to lower the barrier for programming. If we add other complexity here, that would scare off some new users. So the CyberGISX platform is our solution to the issues I listed above. So CyberGISX platform has 4 key components. The first is the CyberGIS Hub. So it's a web interface for you to discover and share notebooks and other related resources. And the second part is the CyberGIS Jupiter. That's where you will spend maybe most of the time on this platform to do interactive computing. And here we already built in a lot of geospatial libraries for you. Out of the box, you can just pick them and use them. And also we have built in our CyberGIS tools for you to do even more. The third part is the CyberGIS Compute. So sometimes you need to expand your research, right? You need to use the high performance computing to do a large scale modeling. So how to do that from Jupyter? That's the way to do it. Use our CyberGIS Compute web service. And also we have the CyberGIS Wiz. So it's a collection of tools for you to do more advanced geo-visualization on the CyberGISX platform. So next, I will quickly go through each component. So the CyberGIS Hub provides one-stop access to the CyberGISX platform. You can log in using your organizational account. So in our case, just use your UIUC account, you can log in them. Also, we support more than 4,000 other institutional accounts covering different universities, research institutions, organizations. And also on this hub, you can quickly discover the notebook other people shared. And also you can find the notebook we provided, example notebook, and you can open them Here you can leave comments and the author can reply your comments. And then just with one click of this button, there's a button called Open With. You can open the notebook in the CyberGIS Jupiter environment and run the code in live and reproduce others' work. And also, once you have developed your notebook and you want to share your notebook with others, you come back to the hub and register your notebook and share it with the community so other people can find your work and run it and build on top of it. Also, if you're a blogger, you can publish blogs on the CyberGISX Hub, on the CyberGIS Hub, so to boost your visibility of your research. And for every user, we provide a professional profile page with your notebook, with your contribution highlighted. So you will have a link to your profile page and you can share it around. So that's the hub. The second is the CyberGIS Jupiter. As I said, that's where you will spend most of your time on this platform to do the programming. So currently we focus on the Python language for now, because Python is the most popular language in data science, in geospatial domain. But we are also looking into adding more languages like R and other coding languages. And on the CyberGIS Jupiter, we pre-installed a large collection of geospatial libraries and our own CyberGISX tools. And also we provide example notebooks to instruct you how to use this different kind of tools. The notebooks are available on the CyberGIS Hub. And also the collection of geospatial libraries include both general purpose libraries and also domain specific libraries. We group them into different kernels. So the kernel is a terminology used in the Jupyter notebook. So that means the Python environment with third-party libraries installed. So currently we have different kernels for you to choose from. We have Python 3, that's for general programming. And we have the Hydro kernel, that's for the water science research. We have GeoAI, that's for machine learning related, and we have other kernels. And also the libraries, the tools, the software, they are not static, they are changing, they are updating all the time. So we periodically update the collection of libraries we host, and also we expand the collection to include more. And also once a library is out of maintenance or is replaced by even better libraries, we swap it out. So we maintain them for you. So you may have questions. Okay, so I build a notebook on top of some libraries and later the library they changed. How can I make sure my notebook still runs? That's a good question. So that's why we provide version kernels for reproducibilities. The version kernels, that's like a snapshot of the environment, and we store there all the time. So if you have an old notebook that is tied to this version kernel, and your notebook will run. Also, for advanced users, we provide a way for you to customize the environment. You can install your own stuff on top of it to meet your specific need. A little bit of detail on how we develop the CyberGIS Jupiter. So the CyberGIS Jupiter is built on top of the virtual Roger supercomputer here at UIUC. So the Roger is the first geospatial supercomputer. And here on the Roger, we set up several virtual machines or servers. And also, when you come to the CyberGIS Jupiter, you will be assigned to a virtual machine, and your CyberGIS Jupiter environment will run inside a container. It's called a Docker container. So in this deployment, we can support multiple users, and also it's scalable. So if we have more user coming in, we can spin up more servers. And also each user is isolated in the container. So anything you do inside your container will not bother other people. So this is how we implement the separation of users' environment. So the third part is the CyberGIS compute. Let me go back a little bit. So even though you can access the CyberGIS Jupiter environment on the virtual router, and this environment is much more powerful than your normal computer already, but in some cases, you still need to access even larger computing resources. That's why you want to use the high performance computing, because it provides powerful resources for computationally intensive jobs. However, to use the HPC versus the high performance computing is not easy. First, it's not accessible to everyone, right? Because the equipment is expensive. So normally you can get an account through your institution or through a established partnership of a project, but it's not accessible to everyone. So also the HPC, high performance computing, is built for general purpose. So it lacks geospatial tools and libraries for you to do your geospatial analytics. And also it does not have a interactive visualization. So you have to use command line to talk to the high performance computing. And when you do your modeling, you need to use big data. So you need to upload the data to the HPC and then run your model and then retrieve the result and download them. So the data handling is extra. You should do it by yourself. And also the learning curve is pretty steep. Yeah, you don't want to spend half your semester to just learn how to use HPC before you can start using it, right? So our solution is the CyberGIS compute. So we wrapped all these complexities inside this CyberGIS compute web service. So you just use the CyberGIS Jupiter. You use the Python to talk to our compute service, and our computer service will talk to the HPC on behalf of you and handle all the complexity here. So you just use Python. And also, if you have a model you develop for the CyberGIS compute, you can share the model with others. Other people can reuse the model and feed in the model with new data and run them on the HPC as well. So the last component is the CyberGIS Wiz. So it's a collection of softwares that can be dynamically configured to visualize high-dimensional geospatial data. So for example, we have high-dimensional data for the same area, and you can visualize the different parameters at the same time. And also we support different types of charts. And the map is linked with this chart. If you zoom in on one map, all the linked maps will zoom in. Also the chart will update. And also we support different types of visualization, different type of layers and charts. Okay, I think that was a high-level quick introduction to the CyberGISX. Next, we move on to our hands-on session. So before that, any questions so far? Okay, so Nathan, could you help paste the URL of the CyberGISX to the chat so the audience can open the platform in the browser? Okay. Yeah, so in the chat, you can copy this URL into your browser. And for new user, first you need to register with our system. So there's a button here, register with CyLogOn. So when you click it, it opens this page. this page just tell you what would happen in next page. So you need to click this, continue to say log on. And then there will be a drop down. You search for UIUC and you select UIUC and you click on the log on. That would redirect you to the UIUC login portal. And you need to go through the two-factor authentication. That's you do, yeah. When you log into the other service, UIUC service.
So this is just using our NetID username and password for Illinois. So just go to the link that was shared, click on the register button on the top, and then fill out follow the steps there. Once you do that, you should automatically get access to CyberGISX.
Yes. Once you log in through the UIUC, you will see this form. So I think the full name is automatically filled for you, and your organization email and your university. And here you need to provide a username. Provide a username for the CyberGISX, and also your role. You can pick from the students, instructor, researcher, or other. And also we support creating new account using Google. So that means here you can search for Google. You can use Google account to create account with us, but that would need additional manual approval. So in that case, please put the GS day here in the comments. So our administrator, Nathan, will manually approve you. But if you use UIUC login, you will get approved automatically.
It is recommended to use your university credentials if you have that. Only for people who don't have university credentials, please use Google. But I think most of the people on this Zoom have university credentials.
So if everything goes well, you will come back to the main, the first page of the CyberGIS Hub, and you can see your username here. So we're good?
Anyone having any challenges, please feel free to speak up. We see that there are a number of registrations coming in, so that seems to be good.
But the very first thing that you said about where we first click to get down to the page that you have now, is it the underlined URL at the top of the screen?
Yes, and it's also in the chat.
It's also in the chat.
Again, repush.
Great, thank you.
Awesome.
Anyone else having any problems getting an account?
Yeah, since we do not have too many people, you can just unmute yourself and speak up.
So we click to register with CI login?
Yes.
Register with CI log on, and then the next page, you click continue to CI log on. And then you need to type UIUC to search for the UIUC. Let me quickly end this one and okay.
Yeah, I think that would be good.
Yeah, so now I logged in. So let's quickly walk around on the hub. So the hub, I'm still sharing my screen, right?
Yes.
Okay.
Fine.
That's great. So under the get started drop down, you can find some videos here. Actually, that's walk you through the step you already did just now, how to create an account. Also, we have knowledge base. you can find more advanced feature here. And we have the FAQ here. And we periodically update this based on your feedback. And if you click the Discover, you can find the notebooks, example notebooks we provide and the notebooks other users shared. And you can do search here. For example, you can search for GS Day. And the first one is the notebook we'll be using in the later session. And you can click on a notebook. And here, each notebook comes with the abstract to give a short introduction on what it does. And also you can see the full notebook here. But this is only the view mode. If you want to run it, you should click the open with CyberGISX. That would open the notebook in the CyberGIS Jupiter. So you can do a live run there. We will do that later. Yeah. So if we come back to the community, and we have different items you can click on here, notebook showcases. So here we have some getting started notebook to talk about the basic of Python programming and how to do development in the notebook. And also we have some examples on the visualization analytics. And also we have some project or community-oriented sections, like here, geospatial fellows. That's a project we are working on. So we have notebooks contributed from different geospatial fellows to work on the COVID-19 research. And we can come back here. We have HydroShare. That's the notebook contributed from the water science community. And we have the Where COVID-19. So that's the notebook we provide for the COVID-19 research. And also you can click your name here, your username here, that would open your profile. So I think for now, maybe you see an empty profile because you haven't created any notebook. But if you have notebook created, you will see your notebook here. And you can put your short resume here, picture, and also if you have blog, your blogs will show up here, and you can share this link with others. Yeah, so let's give people maybe 3 minutes to play around with the hub.
And in the meantime, if you have questions, feel free to unmute yourself and ask.
Okay, so let's continue. So next we will open a notebook and we'll run it on the CyberGIS Jupiter. So you can click Discover and search for GS Day. The first one is called Getting Started with Interactive Mapping and Data Visualization, GS Day Workshop. You can click this and then click the Open With button. That would open this notebook in the Jupyter environment. So if this is your first time click on the Open With, you will show, you you will see the login again, but you can just click this button and that would open the notebook automatically. So I can show you here. And this is only the first time when you click on a open with button. So later the login will not show up.
So were you guys all able to follow what Drew was doing in terms of getting that notebook, searching that notebook, and then opening it with CyberGISX? Please feel free to interrupt. It's difficult to do it in a virtual session. We cannot walk around and see what you're doing, but do feel free to raise your hand, interrupt. It's all perfectly fine. So again, go to the CyberGISX kind of the hub page. Click on Discovery.
Yep. And a search for GS Day.
Yeah.
And the first notebook. Open it and click the Open with CyberGISX.
So once you do that, as Drew showed you, you are in the CyberGIS Jupiter environment. It's like some of you might be familiar with Jupyter look and feel, and you will see a similar look and feel here. It's of course running a Jupyter hub. So all of you are running actually on the same kind of things, but you have your own containers or your own kind of environment.
Right.
There is a question in the chat. Yes, I can.
A question in the chat.
Okay, so let me. Oh, yeah, Nathan got it.
Okay, thank you, Nathan. Okay, so let's quickly go through the basic of Jupyter Notebook. So the Jupyter Notebook is organized into cells. So like here, this is one cell. This another cell. This another cell. So each cell you can run. Each cell, the cell is the basic element to organize your code or your content, and you can run everything in the cell at once. So to add a cell, so first you need to click on an existing cell, and then you can go to the menu, insert, and you can choose to insert a cell above or below. In this case, we just insert above, right? And to delete a cell, you click the cell you want to delete, and you go to the menu. You go to the menu here and add it. And then you choose delete cell. So that would remove it. And also you can reorder the cell. You click a cell and you click this icon to move it down or to move it up. So there are different types of cells, but normally we work with two types. One is the code, one is markdown. So the code is the cell you can write Python. You can write Python into it and you can run it. The markdown is the cell you can write your text, descriptions, comments there. So currently, like for example, this cell is a markdown. So if you double click it, it will show the markdown script you wrote. And you want to render this markdown, you just click this run icon. So that's how we create a cell and the types of different cells. And also the kernel. So as I mentioned, the kernel is a Jupyter term. It's a Jupyter thing. So kernel means the Python with the libraries. So by default, the notebook is always associated with a kernel. So in this case, it's associated with the Python 3 0.8, but you can change to use a different kernel. For example, you can click the kernel here and change kernel. We have different kernels. But in this case, we just stick with this kernel. And also, if you want to see your file tree in the Jupyter notebook, so there are two ways. So if you still have the hub page open, so you just click on Launch CyberGISX. That would open the tree view for you. Then you can find the file of your notebook. I think in this case, you will see only one folder. It's called GIS Day. And then you can go inside it and see your notebook here. You can click it to open the notebook. Another way is you can come to the address bar here. You can remove the last part. In this case, it's the file name of this Jupyter notebook. You can delete this part and enter. That would open the tree view. That would open the file tree for you.
Drew, there was a quick question in the chat in terms of how they got some empty notebook. Brian, do you want to elaborate? Can you see this now? Like the link I posted, and you can click on open with. Are you still getting an empty notebook?
I was following that just now. Yeah, when I started up, I just got a blank Jupyter page to start up a new notebook. Right. But from that page, I should. Okay.
Yeah, for everyone, I guess you can go to that page which I sent. That if you did not find it on Discover or had some problems, you can directly go to that page and then click the open with.
Click the open with.
And it should open the notebook which Drew is currently showing.
Thank you.
Yep. Anyone has problem, feel free to interrupt, put it in chat. Yep. Really appreciate it.
So we have some small tasks here for you to get more familiar with the Jupyter environment. So yeah, I think that you can quickly go through this task to try to add a cell and change the cell type to Markdown and add some Markdown, and also try to run a Python code and then clear the notebook. There are 4 tasks here for you.
Let's maybe give people 2 to 3 minutes to get this done. Any challenges, let us know. It's very simple task. Maybe another minute or so. If you're not done, just please say hey, or please put a reaction or put something in the chat.
You can see here we have a bug report button. So when you use it, if you see any bug, you can click this button. That would open the problem report form. So let's continue.
Everyone is caught up. Any challenges? Yep, I have a question there in the chat. We have numerous errors. Which browser are you using, Brian?
I was
Safari?
trying Firefox, but I got like a CI login authorization endpoint at one point, and I don't quite know how.
Yeah, can you try again? I guess did you get it on CyberGISX at all?
Yeah, it went there, but I never was able to get to the page that you mentioned.
Oh.
So I'm not sure why what I did wrong, but
Yeah, if there is a, I guess the recommended is Chrome, as Nathan said, but it should work on other browsers, though it has not been tested extensively.
sure. I'm trying Chrome. But I don't want to slow down everything you're trying to do, so that's okay. Go ahead and proceed. So.
Yeah, okay.
Okay, so let's continue with this notebook. So in this notebook, we will give a brief introduction on geovisualization techniques. So here, we will go to the Illinois Department of Public Health to get some COVID data. And then we will create a map on weekly change of new cases at the county level. And also, when you click on a county here on the map, it will show a time series of new cases for that county. So that's what you will get in the end of this notebook. So, okay, so yeah, my screen is a little bit laggy now due to the Zoom. Okay, so first here, we list all the libraries we are going to use and their short introduction on each library. You can run the cell with me. I think let's start with this. So to run a cell, single click on it and then Shift plus Enter. Or you can click the cell and click the run, this icon. So this is to import all the libraries we are going to use. And then next, we are going to download the latest COVID data from the Illinois Department of Public Health. And run this. You see the data is downloaded here. It's a CSV file. And here we use the Panda to read it into a data frame. Okay, so we can quickly examine the data. So each line is a record reported for a specific county. And we have the data all the way from March last year to yesterday. So normally the IDPH will update data at the noon. So it's still 10:40. So the latest data is yesterday data we get. And the data structure is something like this. So each row is 1 day data for that county. And we have multiple rows because we have multiple counties. And we have multiple sections because we have multiple days. So this is a row data in this structure. And here we can profile the data from different angles. So first, let's run this to get all the county names. So here you may notice we have a Cook County. Also, we have a Chicago. So Chicago is a special case here. The public health department, they take the Chicago out of the Cook County and they have a separate record for the Chicago on each day. And the Cook County's data does not include the record for Chicago anymore. So they separate Chicago from Cook County in this case. And then here we can pick a county or city, in this case Chicago, and we can look at the time series for that county. So here I get all the data for Chicago. So that's the March 17th last year to yesterday. And on each day, they report the cumulative cases. So that's the total cases as of that day. And the case change, that's a new case. And also similar, they have the total tested and the tested changes, that's a new tested, and the deaths, total deaths and the new deaths. And then we can plot it to get a time series. This is for Chicago. New cases, new COVID cases on each day from last year, March, to yesterday. So here we use the pandas built-in plotting feature. Underneath is using the matplotlib. So we have a link here at the top. So if you want to learn more about the matplotlib, you can click here to get more information. So here we can clearly see the waves, right? Looks like last year around the November, that was the peak. So apparently last year GIS day was a hard day in terms of the COVID. Yeah. Because today or yesterday we are much better. We were much better than the same day from last year. So this is for Chicago only. I think I can give you 3 minutes so you can play with this section. You can try to change the county name. So to find a county name, you can pick a county name from here. For example, I can pick for Champaign. Where's Champaign here? You can copy and paste, replace this part, and then rerun this cell, and then rerun this cell. Then you can get the data for Champaign, and you can plot the data for Champaign here. And also, if you can plot other metrics. So to find a matrix, you can copy the matrix name from the header. You can try the cumulative cases or the tests, total testing or deaths, and update the plot. Let me try another county, maybe the first one, maybe this one. Rerun this cell, rerun this cell, rerun, and get a new plot. So far, so good. So you can get this plot, and you can change the county, and to get another plot you want, the time series. Okay, so next we will do a geo visualization on the map. So in this case, we'll be doing a weekly change of new cases for each county. So it's pretty simple. So we have the time series for each county. You just pick a day, randomly pick a day, and then we look back for 7 days. We calculate the new cases reported within this week, and then we look back for another 7 days. We calculate the new cases reported within this week. So for the first week, we call it current week, and this week we call it last week. To calculate the weekly change, we use the cases reported for current week minus the cases from last week and then over the last week. It's pretty simple. So there are some edge cases. So if the new cases from last week is 0, that means here is 0. We will get a infinity number, right? but that's fine. In the visualization, we can handle that. So you can run, in this case, I just picked the yesterday as the day 0. And then I run this cell to calculate the new cases reported for this week and the last week for each county. So that's the number. Here you see the Scott. Okay, that's the edge case we got here. The Scott County had no new cases from last week, but it has new cases from this week. So when we calculate the rate, this will result in a infinity. But that's fine. So here, that's how we calculate the change rate. We use the pandas. We can do math between these two columns, and we sort the change rate. You can see Scott got a infinity here, and also the Brown has a negative value. That means the cases is decreasing, and this county got a positive value. That means their cases are jumping up. So we have the weekly change rate for each county. Then before we can visualize them, we need to classify the data and assign the data with different colors so we can put them on the map. So here we do a manual data classification. So we have 5 classes. The first class is if the change rate is greater than 50%, that's class 1. If it's between 10% and 50%, it's class 2. And then if negative 10% to 10%, it's class 3. And if it's negative 10 to negative 50, it's class 4. And if it's lower than negative 50%, that's class 5. And we have a function. So the function takes in a change rate value and compare it with the boundary we set and return the class value or the class indices here. So we run this. Oh, so my mouse is freezing. Okay, now it's moving. And we apply this function to this data frame we got. So we classified the data. So now each county has a class value. And the class number indicates the situation of their new cases this week compared to last week. And next step, we need to assign a color to each class. So the library, there's a question? Oh, no, sorry, okay. So the library we are using has a lot of built-in colors we can choose from. So for instance, you can uncomment this line and you can run this cell and you can see a okay, you can see the different colors you can choose from. In this case, we already chose a color map. So for the red, we will use red to represent the cases are increasing significantly. And for the green, that will represent the cases are declining significantly. And the yellow will mean, okay, it's relatively steady, no big changes. And if you run this cell, so that's how we assign color to different class. So class 1 got red, class 5 got green. And then we apply this color map to the to our data and visualize on the map. Here we use IPy Leaflet. IPy Leaflet is a Jupyter wrapper for the Leaflet. I think some of you may heard of the Leaflet. It's an open source library. You can do geovisualization in the browser. And the IPy Leaflet add support for the Jupyter environment. So first we create an empty map. This only has the base map, and it has the zoom in, zoom out, and the layout, and the layer control. And then next, we have a Geojson. Geojson has the geometry of all the counties. We read in the Geojson, and then we put the Geojson and the classified data and the color map together into the IPy Leaflet. That's how we create this map. Okay, so now it works for me. Yeah, sorry, I think we are running out of time here. And we can add a legend to the map. So you can see which county is doing good, which county is doing worse here, based on the data we got from IDPH. And the last step, we can combine this plot with this map. We combine them together. So when you click something on the map, that would plot the time series of new cases for that county. And one thing I should mention that this metric is only for demo purpose. And this metric, the weekly change metric, if you use this metric alone, this may mislead you. Because for example, if, for example, we calculate the weekly change rate for Chicago in last year November, because Chicago at that time was on top of the curve. And the changes between different weeks, they're pretty small, but they're on top of the curve. In that case, we will get a very small weekly change rate. So on the map, it would show, okay, Chicago is steady, but it's on top of the curve. So that's the worst case they got. So there's no one metric can show you all the pictures. In real analysis, you should use different metrics to analyze your data from different angles. So you got this map work for you? Good?
It did, thank you. This is really fascinating. It's a lot to take in when we go back and look it over. So
yeah, one thing is we are running a little bit behind, I guess, in terms of we are almost to the end of it, and some of you have to go to the gather sessions and things like that, which is good. But any quick questions for us? The other thing I should say is this environment is available to you. It's open to all of our faculties and students. So you can use it even after this GIS Day event. So you can use it in your classes, in your research. If you have anything, if you have any questions about using it, you can reach us. Maybe Drew, you can share the slides back and just put our email addresses and stuff like that, so people know how to reach us. But yeah, this has been used in a lot of our research and educational activities, and it is a product of a number of years.
Thank you for your time putting this together and sharing it with us.